Thanks, everyone. So there are two names here that you'll see. Unfortunately, Neil got sick this morning. He sent me progress reports all through the morning of how he was getting worse and worse. And having endured a birthday party for his 3-year-old son, he then put himself to bed. So the talk today is going to be about our experience at JPMorgan of running a Python infrastructure at massive scale. The final part of the talk was going to be a live coding demo done by Neil, but he's not going to be here to do that, and so I won't attempt his live coding. I will give a kind of impressionistic view over the slides that he was going to present, and then quickly switch to questions that you might have. So, first of all, just to introduce JPMorgan. So, JPMorgan is one of the biggest banks in the world. Not really a household name in the UK, but as far as banks go, pretty big. So a couple of nice round numbers there. I guess the nicest and roundest number of all is the revenue is $100 billion last year, so that's quite large. And the bank has 252,000 employees globally. So that is a very large company. Now, on the tech side, most people don't think of JPMorgan as a technology company. Maybe for you guys, because you're a lot closer to these types of things you do, but JPMorgan has 44,000 people that work in technology. And the total budget for technology is nearly $10 billion. So very large tech organization, and within that, Python is very, very widely used. I thought about listing some of the areas that Python is used within the bank, but basically it's used in most parts of the bank to solve pretty much every conceivable problem that people have. So I won't list them. I'll more talk about how we actually use Python in our day-to-day work. So the topics I'm going to cover today will be focusing on Athena. So Athena is a Python-based trading platform that is widely used across the investment bank in JPMorgan, and I work in the Athena core team. So it's a team of about 140 people that build the core infrastructure for that trading platform. Then I'll go on to describing how we actually make the platform work at the scale that we do, and the code base is 35 million lines of code at the moment, so that's pretty large. And then touch on the bits that Neil would do. So Athena is a platform that started in 2006, originally targeted to be a risk management framework for FX options. So very much it was conceived as a start-from-scratch project to do things in a way that enabled developers to be very productive to meet the needs of a trading business that was trading complex derivatives. The starting point was in FX options. The users were the traders of FX options and to some extent the sales team there, and the work of tailoring the platform to the needs of the desk is done by small teams, small desk-aligned teams. So typically there would be teams of maybe 4 or 5 developers working with a couple of quants who would be building out, say, the FX options specific functionality, or FX cash, or precious metals. I used to run the precious metals technology team, and we had 5 people between London and New York. And this functionality was all built using the underlying platform called Athena, built by the Athena core team. Now, the overall development approach for this was focused 100% about rapid application development. When you're starting a brand new project that says, we're going to do something as ambitious as building a trading platform. You're coming into a business that basically says, we don't think you can. Plus a lot of other technology teams that say, we don't think you can either, because if you're successful, you'll replace us. So you start with a small kind of skunkworks project that then kind of runs like crazy to try and build enough functionality to prove that you can actually do it. And you have to build the credibility as you go. So that meant that from the start in 2006, they had to make very, very tight decisions about what the infrastructure was going to be and how it was going to be supported. So they built a very narrow stack of tightly integrated Python components, really pushing the limits of what Python was at the time. And these are screenshots from the training manual that I used when I first joined in 2010, showing some of these components. So there's a launcher for the trading applications, a trade blotter showing elements of the deals booked, a risk report, and then a chat application called PIMS. Now, the different colours are for different people, so you can see instantly what's gone wrong in which part of the business. The bits that you don't see from this in the stack are underlying it all is object-oriented database that we call Hydra that basically enables trading to take place simultaneously in all the different trading centres around the world, does optimistic writes into each of the local locations, so New York and, say, Singapore and London, and then will replicate transactions between those databases. And if you have designed things well, there will be no conflicts and everything will merge and you'll quickly get a consistent view of your global trading position. If you haven't, if you've got conflicting rights in different locations, then you'll screw it up very quickly. So clever use of having simple technologies. Now, Hydra is based on pickling Python objects very simple. It's actually based on Zope if anyone was using Python around the year 2000, but sort of very much extended for a global trading business. Also, one of the decisions that was made very early on was to run all of the source code and the development in a mono-repo. And the idea was you'd have developers globally, small teams on all of the trading desks, and you want everyone to be developing from the same code base. This was a long time ago and the very early stages of the project. When I say it had an informal software development life cycle, it basically means it had no real software development life cycle, no real separation between dev and production. Things would break all the time, but somehow it was small teams that knew the stack well, that knew one another well, that were able to recover from anything that went wrong. And it was a great foundation. And you need to run quickly at the start to get the runs on the board, to have the credibility with the business, to then reinvest and grow. So the scope of Athena, as it took off, grew enormously. So I joined in 2010, which was 4 years into Athena, just as it was expanding from FX to precious metals. Precious metals is traded a lot like a foreign currency. So Precious leveraged a lot of the FX stuff, although you have vaults full of gold bars and things like that you need to track. Then the next business on board was commodities, and then in the following years, credit and rates, and then parts of equities. But equities has a lot of really high volume trading that Python struggles to cope with. But Athena grew largely. Also, the controls around what we were doing increased enormously. So anyone who's worked in banking knows that you have lots of different teams that check what each silo is doing to make sure they're doing things right. And in particular, we'd have market risk teams, credit risk teams, valuation control groups to check that traders were pricing things correctly. All of these people started off running their own pricing stacks to do independent valuations and risk calculations. What was realised very quickly was that it makes no sense to do that where you have so many different parties across the bank having their own models, their own versions of the truth, and to a large degree they have converged on using Athena to give a single view and a single consistent methodology for pricing everything. So that's how Athena sort of grew subsequently, and right now we're at the phase of a whole new growth in the use of the Athena platform for data science and machine learning. And that brings very different challenges, and I'll get onto that later in the talk. So these screenshots here are from a more recent version of Athena. They look a little bit more modern. This is from Athena Trader Desktop, which has been the main GUI platform for the last 3 years. Now, over the 12-year history of Athena, the size of the code base and the number of developers involved in that has grown enormously. This graph is the number of active developers per month, and these are people that are committing code. There's a whole bunch of other people that might write code but not actually commit it into the production code base. So we have 1,600 developers a month committing code. The number of commits per month is around 60,000, and the total number of files in the source control system is around 500,000. So this is a large code base, and essentially when we're developing code and you'll want to see whether someone has written some code before that does what you want, and you do what the tool that we use is called Glimpse. You glimpse through other code that's been written, you'll be searching through a code base that's this big. Interestingly, you'll see here the commits per month has a dip each year, and this is an end-of-year code freeze. No one wants systems to break around the end of year, especially with people away for Christmas holidays. So around from 2011, there was a code freeze instituted. Before 2011, people just went hell for leather, committing code regardless. That's a sign of the maturity of the business. So when you have a situation where you've got 60,000 commits a week to a code base, it's quite a difficult challenge to see how do you actually make that work safely. It feels like the whole world is changing underneath you. So I'll talk a bit about that. So from the start with Athena, one of the aims that everyone has worked for is to make it scale for developers to be productive. And that's important because we want to deliver functionality and we want to deliver it quickly, and also we want developers to be happy. There's nothing destroys the happiness of a development team than having a whole lot of bureaucracy that they have to step through. And we see in some other parts of the bank that operate in a far more traditional way, they're forever preparing for a release or preparing test environments or preparing to migrate and do things like that. And somehow in our world that doesn't happen. We just write our code and get it into production. Now, the way we do that is through continuous deployment at 2 different levels. Now, we have the sort of core, so we split the code into 2 halves. So the bottom half is the core Python distribution. And so this is the standard Python plus the mainly binary libraries that we have decided make up the core of Athena. And then the second level is the application Python code, which is effectively what all of our developers in our organization write. And that has a different process. So I'll briefly talk about this one first, and then over the next couple of slides go through that. The SDLC that we have for the Python code that say front office developers write all the time is very simple. You write the code, you write test cases for it, and then commit it into production. And then there's a stage gate where someone from the team that code is sensitive to needs to bless it. And this is the kind of the approval stage for going into production. Once code has been blessed, then it can be pushed in production. And from that point, it's live. And so anyone globally running that application or an application that uses that library will get the latest version of it. And that means that the whole development experience is something that's, I guess, very rewarding. And for a trading desk, if they see that there is something that is broken, a particular type of deal is not working or something like that, then we can do an immediate fix and get that pushed into production for them right away. I think there was a question over there.
Yeah, so maybe I missed it, but can you explain briefly what this thing does?
The trading platform.
What are the functionalities of it? Or?
Okay, so in the narrow sense there, the trading platform is you have salespeople that are taking orders from customers for particular financial deals, and so they need to price a particular, say, structured deal to that customer. The customer might be a hedge fund or an industrial user of metals or someone wanting to hedge currency exposure or any number of end customers. They will want to do some kind of financial deal with the bank. They get a price for that. It gets quoted. They accept that. Then a trader will book that deal into the systems, and normally that will involve the bank taking on a risk, a financial risk for the customer, and there may not be an exact match for that product in the market. What the customer wants. So the trading desk will split apart that financial transaction into simpler things that are traded on the markets, and they will hedge their exposure like that. And as a trading desk, you make your money from the spread between the price that the customer pays and what you can do to hedge that risk in other markets. So you need to understand the risk exposure that you have from taking on a deal. You need to be able to book the right components of that, say futures, trades, or things like that in other markets. And then as you have a portfolio of trades, as the market prices and risks are moving, you may need to re-hedge portfolios continuously. So that's the kind of the trading desk view of the world, and then there's a whole lot of other things around settling trades, regulatory reporting, all the financial and accounting aspects. And so the Athena trading system does many of the parts of this end-to-end process, plus a whole lot more analysis around figuring out basically how to run every part of a trading business. Okay, so for this application level Python code, the idea is that as soon as the code has been saved or has been blessed and formally pushed into production through the software development lifecycle, it's there to be used for any application. I'll talk a bit more about some of the controls we have around that so that works smoothly. But first talk about how we manage the staging of new versions of the binary Python distribution. So essentially, we have one version of the Python distribution. I'll use the slide here, which is Python talks about its libraries being with batteries included. Well, the Athena Python distribution is sort of batteries and steroids included. So the full distribution is about 5 gigabytes, and this is something that is pushed out to run on all of the machines, whether it's Windows or Linux machines in clusters. They all run the same set of packages.
You're using Python 2.7, is that right?
We are using Python 2.7 internally. I'll talk more about why that is at the end in a question, if you'd like to ask that in a question. But yes, and that will change in the future. But there are good reasons for that, but I'll talk about that at the end. So the idea is that this collection of packages gets upgraded each week, and we think of these versions of the packages as a bit like a train. So each week, the sort of candidate for release prod.new moves to prod, then the previous prod becomes prod.old, and these are accessed by setting up a Python path that has directories for all of these. So these are like build numbers. And so you can see that between prod and then next week's prod.new, there was, 417 more builds of that. The prod.latest is a continually built version of that with a whole lot of unit testing going on. And then when that gets cut to a release, it goes to prod.new, and the developers and all the dev infrastructure run on prod.new for a week to shake out any incompatibility problems. And then the live trading system runs on prod, and then the old version of prod is kept around for another week, so that if the process of rolling out prod uncovers any unknown bugs, then particular applications within Athena can run for a while on that old code while that's resolved. And this is a really simple way of doing a distribution, with the downside that the full set of packages is 5 gigabytes times 4, so that's a 25 gigabyte distribution. And this is one of the things we're trying to solve now when moving to cloud-based infrastructure. You're setting up your code in some kind of container and shipping it out, and that's 20 gig of code there. And we try and make it easy for people to switch between these environments because it's important to recover quickly. So here from our main application launcher, you can just right-click on an application and run it using any of these other environments. So that makes it super easy to run from prod, but have the safety of being able to roll back. Now, the more interesting layer here is how we manage the continuous deployment from the application level code. And the way we do that is the source code is not stored on the file system, it's stored in Hydra, our global object-oriented database. And so when an Athena application runs, it has a couple of parameters here specifying what to use. And so the source database, PS, is prod source. So a real-time forwards viewer for Boolean, looking at gold, XAU, and runs on prod source. And the way that works in practice is within Python, use path hooks to have an import hook and have a special importer that rather than loading source code from the file system will go out to this database and pull back the source code or more accurately the compiled source code to run that. And we have wrapped versions of a lot of libraries, so like the standard Python module of logging. If you load that, it's loaded from the file system. If you load lib.logging, which is the Python wrapped version of it that's sort of hooked up into all the infrastructure, then it actually comes from Hydra. And we can show that these modules are just normal objects by opening the object database and reading them. And the actual way they get executed is the standard way for Python modules. So that's the way that we're able to do continuous and instant deployment of source code globally at this scale. If you want to learn more about import hooks, so there's a couple of PEPs that have been written about that, and also some projects that are on GitHub or on PyPy that will use the importers. Now, as part of helping it make developers productive, another thing that we do is with our object-oriented database, be able to do what we call unions of the database. So a lot of the time in traditional IT organisations, they're creating test environments and sort of then the data needs to get refreshed and everything like that. Whereas the way we run things, we're able to specify combinations of databases just with a semicolon, and the infrastructure transparently will stack these together. Any writes go into the front database, and reads will happen from the back ones. So we use that for archiving, for instance. So you can have the main production database and removed old deals out of it, but you can put those old deals in archive databases and have a transparent way of accessing it. Operating geographically, you can specify an individual geographical host rather than picking the nearest. And if you're writing tests, you do something like this, where you have a test database in the front, your line of business operational database in the middle, and then some common bank-wide, say, reference data database in the back. And it all, you run your unit tests, the test objects will end up here, you can check them there, and then you can nuke that database, and it will be clear again the next time you run tests. So that's a very convenient way of not having to have expensive operations to set up environments for doing testing. Also, from source databases, you could do the prod source is the PS, but we also have personal staging areas, and so these operate in the same way. Your own staging area is stacked in front of the back-end database, and so you have a personal area there. If you want to do development as part of a team for one project, you can create a staging area like that. Although we discourage that because we really want everyone to be working ahead. We don't want long-lived development that gets too far away from the main prod code. And then finally, as part of the software development process, whenever code is needing to be reviewed or to get committed or to get blessed, those source files are packaged up into their own staging area so that they can be first of all seen by the person that's reviewing it, but then also kept for audit purposes. Now this, when you've got all this code changing around you, then you might want to create some kind of stability, and so there are ways where we can freeze these changes at certain points in time. So maybe at the time an application starts up in the morning, you want to freeze the source code there, and so on. Now, to make all of this work, there's a whole lot of tooling, but it's hidden behind the scenes. We use a customized version of Visual Studio that integrates the version control information, so we say who files are sensitive to, the review and commit infrastructure, and see everything there, and also see which people own files. So all of the history around the way we are coding is right there in Visual Studio for everyone to use. This tooling lowers the barrier for improving the quality. Quite strict controls around test coverage and so on. Things like PrevMark checks. These are checks at any time pricing-sensitive code gets pushed. You compare the prices before and after. Sometimes that will reveal bugs. Sometimes it will reveal known changes in how something gets priced. And in that case, the trading desks need to sign off the pricing changes before they can go live. But this tooling doesn't get in the way of the developers, and it means that we can all focus on writing code quickly. Now, having tooling itself is part of the story, and the other thing is, you need to have a big stick to whack people if they get out of line, but ideally you don't actually want to need to use that stick at all. Really, it comes down to having the right kind of culture. This graph shows test coverage. This is for all of Athena, which is there's a lot of legacy code there, so it improved very slowly. Kind of the highlight here is the coverage controls were instituted here, but test coverage didn't really change. It was only when the software development lifecycle commit controls enforced test coverage and things like that, then the test coverage increases. This line here is an example from a newly set up, or a small team in Beijing that sort of quite quickly was able to reach the same kind of levels of test coverage as the rest of the business. It shows, having the combination of the tooling to make it easy, plus the enforcement top-down and by the infrastructure will drive that change. So the end result is Athena has become a very stable trading environment used by getting on for 2,000 developers with 15,000 changes a week, but with a relatively conservative code base using Python 2.7. Now, that doesn't suit the needs of data science, and the team I work with is a small offshoot of Athena called Athena Research, where we are building the same developer experience but geared around data science and machine learning. And for here, our target users include not only developers and quants, but also data scientists who maybe 5 years ago would have been using SAS, but also eventually business users through Jupyter notebooks and dashboards and things. And what we are building out at the moment is an environment that uses the newest Python libraries, but still gives access to all of the rest of the environments that Athena has, while enforcing the separation between the research environment and the more traditional production environment. Some of the challenges that we're solving at the moment is how to give people across many lines of business access to data sources in a way that minimises the bureaucracy. What's the right kind of infrastructure to support scalable storage and calculation GPUs and everything, and how to adopt this software development lifecycle where you have models or where you maybe have Jupyter notebooks, which is a combination of code plus output. These all have challenges for established processes, and we're working hard to build all that out at the moment. So we actually just have, I think we must have more minutes than that left.
Yeah, that's good talking.
Oh, okay, good.
5 minutes more.
I was worried for a moment. Okay, so this is I hope has given you a sense for Athena as a platform and the type of development environment that we've tried to create for very large teams of developers to be productive in a large code base. I'd just like to finish the talk with touching on what Neil would have done for a live coding demonstration with a data visualization component that we've just open sourced called Perspective, which is an engine for viewing streaming data. This has been the result of a number of earlier versions internal to JPMorgan. So a fully Python-based version using HDF5 and grid display with WX Python. Then another version that had a more C++ server-side grid engine. And the latest version is one that moves much of the work that an engine can do to do aggregations and things like that into the browser using WebAssembly. So that's up on GitHub. It's one of the very first pieces of open source software from JPMorgan, and something that we hope will be a much bigger trend in the future. I won't go through these things about the structure of it. Neil would have talked about this. The Perspectives is on GitHub. we have one guy who's built a Jupyter Lab extension that uses perspective for visualization. So if you're interested in checking that out, that's on the GitHub repo, or linked from the GitHub repo for Jupyter Lab extensions. The guy who wrote that, his name is Tim Payne, and we hope to be presenting about that at JupyterCon in New York in August. Also, I guess I should say, we have a recruiting stand here. We are looking for large numbers of enthusiastic Python programmers for all types of work, for data scientists. We have a massive amount of things going on. So please come up to our recruiting stand, come and talk to us, and we can give you a bit of a flavour of more directly some of the work that we do. So, thank you.
So we have time for a couple of questions. Anyone?
You wanted to ask about Python 2.7 versus Python 3. So I think we would all dearly like to be on Python 3. One of the downsides of having the global object store that we used back in 2006 was it stores Python objects by pickling them. And so when you've got lots of these, we have something like 350 Hydra rings, each which are independent sets of Hydra databases, each one be several hundred gigabytes, and we'll have maybe up to 15 or more regional replicas. So that's a huge job to migrate from that established environment into Python 3, but it's something that we know we have to do effectively within the next 2 years. A lot of preparation is going on for that at the moment. Pandas is going end of life with Python 3 at the end of December. NumPy will stop doing new features in the Python 2 release from January, and will then just do bug fixes for 12 months and then stop. So effectively, by the end of next year, we have to have migrated this whole trading business from Python 2.7 to Python 3. So that's prompting a lot of other changes as well. Okay.
So given Python's untyped, how do you and a large code base, how do you manage dependencies between modules and libraries?
So for managing dependencies, so there's a very large testing infrastructure behind that has a map of the dependencies between all the different modules. So not only have your standard unit tests that run when a module is checked in, but we have this big infrastructure of what we call ghost tests that will see what modules are calling any other code, and if one module gets changed, anything that uses that will get all of its unit tests rerun. Plus, there are a lot more integration tests and everything else, running continuously. So there's a very large testing infrastructure behind it. Occasionally, things do break, but a lot of the systems are designed to kind of be to move forward smoothly without needing explicit data migrations, and that's the key.
So obviously you have a custom stack, like a custom database and a custom source code control system. So given the benefits of hindsight, for your new stuff, do the benefits outweigh using a standard like GitLab, GitHub, and a standard database versus an integrated but custom stack?
I think sort of any business, if you could erase all of history and start from scratch today, you would do things quite differently. But you can't pretend that history is not there, and you would not have a business running if you hadn't been through that. So for Athena research, there are there are large elements of Athena that work really well, and we don't want to throw that away. I think one of the things that Athena developers realize if they leave Athena is how much of the infrastructure is there and it just works and they don't have to make decisions about that. It's all integrated, and so they can focus on delivering business functionality. Whereas if you go somewhere else and you think, okay, well, what do I use for this? What do I use for that? You can make those decisions as an individual, but there's a point where coordinating that across larger teams then becomes very hard.
Are you doing Python 3 with your Athena research?
Yep. I mean, one of the key challenges with Athena research is saying, for the sort of trading environments for Athena, you want everyone to run the same version of every module because you want there to be one answer for everything. Whereas in the machine learning environment, everyone wants to run the latest versions of the latest packages. But then also to be able to go back and validate maybe for models that were developed a year ago, why have they changed? So one of the problems we're solving is how do you have many more versions of environments for the underlying binary distribution and then also for the application code that people are using. Then also, of course, the data assets that people are using, those evolve over time. And so where in the infrastructure do we want to provide stability? Where do we want to let people move as far forward as possible? These are all complex engineering and organisational problems, and we try to do that within the established bank rules, the frameworks, but then also need to negotiate a lot of things, with compliance and so on about, well, these need to be done differently for these reasons, and figuring all of that out. So it's a very interesting challenge.
You mentioned quite a bit about your unit test suite and how many, how it's so fundamental to your sort of workflow at that scale. But how many do you have exactly, or if you can give us like a rough idea, like with a code base of that size, and how do you kind of ensure the quality of them as well?
So that's a very hard question to answer. I mean, we've got a lot of legacy code that was live before unit testing was mandated, and a lot of that code is old and badly structured and crappy, and the people who wrote it left a long time ago, and it just runs and you just don't touch it if you can help it. For new code, pretty much every module will have a test module providing high levels of coverage, and then other modules that will do cross-cutting functionality. So I think in large case it would be more than a one-to-one relationship between test modules and the modules for functionality. In terms of the depth of the coverage of those test cases, some test code is really thorough and rigorous, and of course there's some other that is, kind of goes through the motions. And part of that is around making sure that the teams that are doing the people that are doing the blessing of code enforce a higher level of standards on people that are submitting code that's not up to scratch.
So you'd say that's largely down to the teams themselves?
I mean, the tooling is there to enforce metrics and all of that, but and there are reviews and audits of things and whatever. But very much it comes down to a culture where people try and do the best. On the whole, given that we're all under incredible time constraints to do a massive amount with very small teams. But you get the balance right so that it works almost all the time, and if it doesn't work, then it's not in the areas that are going to be catastrophic, and they can be fixed quickly.
Unfortunately, we don't have any more time for questions, but thanks a lot to our speaker. And
Thank you.